Yes, the previous video we have discussed about features of Java, and now it's a simple example the Java program, and you guys already installed the Java software. Now it is working, compilation and execution are not for testing purpose. Okay, so once you done the simple basic example, the same features for the means same commands we will use for the till the code. Now, so here I'm simple giving the one question, right? A Java program to print hello on screen and then print your name on a separate line. Okay. So example, how you can implement the code. The code snippet like this. Okay. The code snippet. So class, you can use any class name. Hello. So access modifier and static is a keyword. Return statement. It is a main method actually, inbuilt method. So inside that I'm using the system order println to print hello, and after that next line printing the name, a simple name. Okay, the same way programmatically if you want to implement, how you can implement it. Okay. So I'm using the sublime text here. Okay, so write the same code class hello. So inside that class I'm taking the inbuilt method, main method. To run Java program we need main method. So inside the main method, so print hello, print hello, and next line you have to print any name. So any name, just I'm giving the ppt the same I'm taking, otherwise you can take any name. So it is a simple syntax for to understand the Java code, how to start the class. Okay, keyword and the class, the starting letter is the capital letter and without numerics, and second starting word also capital letter. So mean that is a camel case or Hungarian notation coding standards. Okay, class open brace and close brace, method open and close, it is inbuilt method. So JVM checks in your file, in your class file contains main method, then only it will start running, otherwise you will get the main method not found exception, you will get it. Now, so just save the file. So Java file extension is the .java, and C language files are .c, Python .py, like that. So what is the class name here? Hello. File name we can use any name, but for better compilation and execution I'm using the same name as the class name as the file name, and execution compilation I will do the same. Okay, just take the hello.java. Okay, so just replace it, already it is existed, just replace. Now, so if you want to compile this file, it is available in my desktop. Okay, so 25 May folder hello.java. Now I need to give the path to your file, then go for the compilation. So I'm opening the command prompt in a mission. Actually it is a terminal name, but in Windows mission, yes, CMD, here is a terminal. So how to give the path? CD desktop. Okay, and CD 25 May. Okay, inside that I have the hello.java. So in that file, syntactically any mistakes are there, you will get the compile time error. If everything is okay, then it will compile successfully. So the compilation command is java c hello.java. Java C is the compilation command. Here the compiler will come to convert .java file to .class file. So there is no errors, compilation done successfully, and it will create the hello.class file. Okay. And if you want to run the file, Java is the execution command who will come here, interpreter plus just-in-time compiler. Okay, and JVM displays your native understanding format. So what is the class name? The same class name we have to give. So what is the name? Hello. Sophia Hill is the next line, your name. Okay. Now, if you want to see the bytecode also, it is a human understanding language .java file. And if you want to see the bytecode, okay, so I'm opening that file. So hello.class file. See, for 4 lines of Java code, what we implemented the syntactically in English language, human understanding language. So after converting machine level language, this many lines of zeros ones. Okay, product class file. So it is a bytecode. So the bytecode is much powerful than other programming languages and high secure also. So it is platform independent and architectural neutral, portable. So because of the bytecode, we can achieve wherever you want to run the application. That is Java slogan, write once, run anywhere. So it is simple hello world example. How it will work internally? Internally, working flow. So the Java code, what will happen? So I told it in the command prompt. So compilation phase, compiler will come to compile .java file to .class file. .java file is the human understanding. .class file is the machine understanding. That is the zeros ones. Bytecode we can call bytecode. Java command is the execution command. The Java command reads your entire bytecode. So inside that Java command, who will come? Just-in-time compiler plus interpreter. So to read entire bytecode and converting native understanding format and printing in the your console. That is a JVM comes to picture. So JVM is a platform dependent. Bytecode is platform independent. Now the internal flow I will show. Yes, so it is a simple syntax. Okay, compilation and execution command. And what is the output? And here you guys I have created a simple the file name is hello.java. So hello.java file using the Java compiler command, compilation phase, converting .java to .class file. The bytecode is the zeros ones. So because of that, we are giving the write ones run anywhere. So here the execution phase coming the Java command, Java hello. So who will come to the picture here? Interpreter plus just-in-time compiler, reading entire bytecode and converting to the native understanding format. So there is internally JVM memory allocations. I will show that also. So what is the memory allocations we have? The memory areas. Let's see. It is internal working for all the Java codes. If you understood that, that is good. And okay, understand it once again. Now, so what is the definition of the bytecode? So I told already. Bytecode is a set of optimized instructions generated by Java compilers using the compilation phase, and the nature of the bytecode is much powerful than the pointer code of C and C++ languages. So high speed. Okay. Next, coming to the JVM. So JVM is nothing but to convert the bytecode, means the bytecode to native understanding format. So that we have the runtime environment, interpreter plus just-in-time compiler. JVM is one of the program developed by the Sun Microsystems developers, means who is the founder of Java language initially. Okay, now Oracle acquired, but previously till 1.6 Sun Microsystems only they are maintaining. So part of Java software whose role is reading the line by line of bytecode and converting into native understanding format of code. So that means the OS means operating system. So here bytecode is platform independent. Okay, that is OS independent, operating system independent, and JVM is OS dependent, platform dependent. Okay, so that is a basic theory. And next, so what are the steps I have given? Java code to compilation, then compiler to .class file, JVM, Windows, Linux. Every operating machine has their own JVM. Means Windows JVM different, Linux JVM different, and Mac JVM different. Okay, so that is the structure. Next, so the JVM internal architecture. So whenever we load the class file, the .class file, so with the help of the class loader subsystem, so we have the bootstrap class loader, extension class loader, and system class loader, application class loader. So using this class loaders, we will load the files, .class files, and provide the memory allocation in JVM. Means, so we have the like class names and method names, and we have the objects, and we have the local variable, static variables, and the threads. and native method stacks with third party library. Okay, native method stacks for the third party library. So all object stores in the heap memory. All the object stores in the heap memory. The class name, method name stores in the method area. Stack area, static data or static variables. But from JDK 1.8 onwards, there is a static variable also comes into the heap memory. But we have stack area separately to store the static data. So once memory allocation done for your class names, method names, and variables and objects and everything, then we can go for the execution. So interpreter plus GSTM compiler, the garbage collector works automatically. So once execution done, the what are the objects we created and stored in the heap memory, the garbage collector monitors always. So I told in the features type, high performance. So what are the objects created here? There is no reference for that objects. Garbage collector collects and destroy it automatically. Okay. So native method stacks interface means the naming interface, Java naming interface to convert to the your machine level language. Okay, this is the internal structure of JVM. Okay, so what is the simple Java code and how to compile and execute? After execution, what is happening here? .java file to .class file and the printing the output. And what is the compilation phase? What is execution phase? Interpreter with JSTM compiler. What is the bytecode? What is the JVM? Okay, so class loader subsystems, JVM internal memory allocations. This is the simple internal working whenever we run the Java program. So always the JVM will comes to the picture and allocate some memory, then only we will go for the executions. So this is simple HelloWorld example, internal working for all the files. So upcoming days, no need to show the every time what is happening in the Java C command and the Java command. So by default it will follow the same approach for all the files. Okay. So next, so here definition of JIT, just-in-time compiler. So JIT is the program developed by Sun Microsystem developers as part of JVM, whose role is to speed up the interpretation phase by reading the entire section of the bytecode. So previously we have the only interpreter. So the compilation phase is fast, execution phase is slow. After adding the just-in-time compiler to the JVM in execution phase, so it speed up the entire bytecode reading with the help of the interpreter plus and just-in-time compiler both we have. So to read the entire bytecode and convert into the native understanding format. Okay. Java is one of the compiler and interpretation based programming language. And what is the garbage collector? So just now I told you. So garbage collector is one of the system background Java programs which is running along with our regular Java program and whose role is to collect unused memory space for improving the performance of Java based apps. So means what are the null reference objects are there? So null reference objects, it will go for the so the null reference objects are the unused memory spaces. That means we can call there is no task for that objects, collect that unused memory, unused references and destined to the so garbage collector. Once you remove that all the unused memory spaces, then heap memory is very so clean and fresh. Again, fresh objects we can create and we can utilize for the upcoming operations like that. Okay, so these are the basic simple program. All the programs follows the same approach. So bytecode and what is the bytecode, what is the JIT and what is interpreter and what is the garbage collector, what is the JVM. So these things common for the all the concepts. Okay. Next, so next video will go for the data types in Java. So how many data types we have and what is the global variables, local variables, simple example and the data types. Simple video on the data types.